Now, for further analysis we need some definitions. So, let us look at some definitions. There is one definition which we have already seen, that is the definition of delay angle alpha. So, this is something which we have already seen, delay angle denoted by alpha. So, the delay angle alpha is given by this sentence, gate current pulses to the thyristor valves are delayed by an angle. See, we use this word angle and the word duration interchangeably sometimes. Okay. So, normally we do not talk in terms of time, I mean delay is associated with time. So, since our independent variable in this course will be angle. So, we do not talk in terms of time, we will talk in terms of angle only. Delayed by an angle alpha with respect to what? With respect to? Yeah, with respect to the instants of natural conduction. So, if continuous gate current is applied, then what we get is natural conduction or diode operation. So, if we give only gate current pulses and that too delayed with respect to the instant of natural conduction, that is what is desired if we want to have control. Okay. The purpose of using thyristor valve is to have control. Okay. We will define some more angles. Most of these definitions, all these definitions are angles only. So, we define a quantity called angle of advance. Denoted by beta. The definition is very simple. It is defined as 180 degrees minus alpha. Right now, it may not be clear why we need these definitions. I mean, it becomes clear as we make further discussion will make this clear. So, let us just take these definitions, then there is a quantity. I mean, I will give the notation first. This is a Greek letter psi with a subscript O, psi naught, psi naught. So, there is no name for this, I mean it is just a notation, but it is defined as minimum angle. So, one can look at it as minimum duration also, if the independent variable is time. Minimum angle for which the voltage across a thyristor valve should be negative after it stops conducting. So, what does that mean? First of all, what is meant by voltage across thyristor valve? Say, please note, voltage across thyristor valve we have defined. Let us make it very clear. Voltage across thyristor valve means voltage of anode with respect to cathode. So, when a thyristor valve stops conducting, that means say whenever the thyristor valve conducts, the current is flowing from anode to cathode. So, if the current goes to 0, we say the thyristor valve stops conducting. So, as soon as the thyristor valve stops conducting, that means the current from anode to cathode becomes 0, then the voltage across the thyristor valve should be negative. Now, what happens if it is not negative for this minimum duration?
Then it is not turned off.
Then it again starts conducting as soon as the voltage becomes positive without gate pulse. That's, we do not want that. See, our intention is to see that the thyristor valve conducts when we want by giving a gate pulse. So, suppose it conducts without we giving a gate pulse, then control is lost. Okay. So, this is something which should be always satisfied. So, there is a minimum angle or duration for which the voltage across a thyristor valve should be negative after it stops conducting. Okay. So, if it is not, then the control is lost. Otherwise, okay, see, let me see, otherwise, see what happens if it is not satisfied. Otherwise, I presume that you are familiar with this. Otherwise, the thyristor valve starts conducting why it starts conducting, because it is forward biased, but it should not start conduct, I mean it should not conduct without gate pulse. So, otherwise thyristor valve starts conducting without gate current pulse. Okay. So, that is something which we do not want. So, psi naught is the notation for this quantity. So, it is in terms of angle. Okay. Now, why we give it in terms of angle is once we have a system, the frequency is fixed, the nominal value of the frequency is fixed. Suppose I have this quantity psi naught given for 60 hertz frequency. Now, for 50 hertz frequency, the value will be same, if not same, it will increase or decrease? It will decrease. Okay. So, it will decrease. Okay. Sorry, increase or decrease? Decrease. Okay. So, I hope it is clear. Say it is the time which is fixed, but why you are fixing it as an angle is the frequency is of course, once we are commissioning a converter, we know that at what frequency it will work on the AC side. Okay. So, there may be slight deviations from the nominal frequency of 50 or 60 hertz. Okay. So, that deviation is minor. Okay. So, there is one more quantity that is defined, that is known as commutation margin angle. So, this has a notation psi. Yeah, this is not same as the previous notation. The previous notation is psi naught. There is a subscript O there. Here it is, there is no subscript psi. So, the definition of commutation margin angle, this is the angle, or if it is in terms of time, duration, for which the voltage across a thyristor valve, now I will say not a thyristor, voltage across the thyristor valves is negative after it stops conducting. See, psi naught is actually the minimum value that is required. Psi is the actual value. So, psi can be less than 0, equal, I mean less than psi naught, equal to psi naught, or greater than psi naught. So, psi should be
more than or equal.
Yeah, psi should be greater than or equal to psi. xi naught. So, we will keep these definitions in mind.